I owe you an update. Yeah, it's been a while since I showed you what is going on with my beer filling machine, and I made great progress. That's why in the end I didn't have time to film it. I mean, I filmed a lot of it. I have hours of footage I could show you me tinkering, but I think it's not too interesting. I'll put in some time lapses for that. But let's start with the most important. We have that machine that's supposed to fill beer. I also made a new GUI, improved it. I even have translations in 3 languages of the GUI. I have all the settings here. Greatest thing I've got to run yesterday is that the whole filling mode works. I have here my compressed air, the pressure regulator. Actually, that thing drives me a bit crazy because it changes all the time. Oh no, now it's at 1 bar. The pressure goes down here into this bottle. This is actually a bottle that's usually to spray insecticides in your garden, but it's a pressure vessel, which I have modified with a 3D printed cover here in order to be able to connect all the stuff. So the air goes in here, and here I have a rising tube where the water goes up there. That's basically my test beer keg, which is useful to simulate the beer keg, as at the moment I don't have it and I don't have the CO2, and I'm very happy I'm testing with water right now because recently I've flooded everything down here because I messed with the software. Good thing here also I have a little valve that I can shut off the water immediately if I need to. That's something I had to add later. Let's start with the mover. Remove the conveyor. This one here. Oh, I'm offline. Yeah, let me connect to the Wi-Fi. Finally, we have a GUI and it is online. So let's start with moving the conveyor. That's referencing. That's moving forward. It's still noisy, but I ordered some silent stepper drivers. I hope they should, according to other videos on YouTube, just be drop-in replacement and make everything more silent. But anyway, silence is not my biggest issue since it's planned for large parties where you already have a lot of noise. So now, oh yeah, a fun fact, we have a little leak down here, but it's just the air bubbling out, so it doesn't matter too much to me because it's a 3D printed part. I should reprint it with a bit tighter tolerances, but not a big deal. So now the biggest one is test the filler. Let me show you that. We go down, we start filling, and we slowly move up the tube, more or less accordingly to the water level. Oh yeah, and this is the add foam mode. So I go up earlier than needed, because that generates foam. And that's on my GUI here. This is the add foam setting, right? And now if I put this to 0 and save the setting, and I do it again with 0 add foam, the tube will always stay in the water for the whole travel. Yeah, my calculation on how to move the tube according to what I'm reading from the scale is not perfect yet. But I mean, it's not gonna make foam, so I have to think about how to maybe optimize this. Yeah, and I'm actually pretty happy about it. But the way was a long one because my new boards I have here, the new generation boards like this. So the new board I made here has the ESP32 directly on the board instead of having the whole dev kit. You see the difference? I mean, this one never really fits. I mean, I had the wrong footprint, and this one is just more expensive and takes much more space than this one. So I switched to naked little ESP32s, which was kind of a struggle. I will need an additional programmer, an external programmer to program it. But the good thing is that I can do over-the-air updates. So basically I need to program it only once. And after that I can disconnect the programmer and upload the new software over Wi-Fi. But the programmer also helps as a debugger, and that's why I still have this one coming out here to get me the data on the serial console, which is down here, where you see all the debugging output from my filling process, where I was looking what is the last scale value, the current scale value, what's the difference, and the difference is proportional to how much I want to move my tube up. And so that's, it's basically a linear function, right? We have a delta weight, and the delta weight we translate it into a delta height to move the tube up, to pull it slowly out while we are filling. And I have a cutoff value, that's the add foam. So if I'm filled by that much percent, I just move all the way up and let the beer drop down into the vessel, into the glass, so that I get the foam. I also have an interesting mode programmed additionally now, and it's Ajax. So before I was reloading manually. No. I took the time to write it properly. So I have here a read sensors mode. Maybe I could make this a bit bigger. So here we have the button is 1. Because the button is a pull up, so it will be 1 unless I press it. And all the other inductive sensors, they also have pull-ups, but they are normally closed. So as soon as you activate them, they will go 1. And what we see here is that the cup-in sensor is still 1. If I go like this, it goes to 0. So that bar, if I go like this, you see it goes to 0. If I go like that, it goes to 1 again. And if I slightly pull it out, now it's all the time 0. But I want it to be 0 when nothing is on it, right? So I can detect if something comes in. If something comes in, it goes to 1. That's nice. But my printer was working overnight. That part also is the slider for the vertical axis, which I already had to reprint with looser tolerances. Now it works because before it was stuck, it was too tight. Now it's too loose, so I reprinted one with better tolerances. Then I have, this is one of the guide rails for the vertical one, where I added just this little piece of plastic, this little piece here, but that will guide me the cable away properly, so I don't have a collision with the stuff moving here, so I can get the cable across here without interfering. So that is also to be installed, but that's not so urgent as it works now, but it's just next time I open it up, I want to change that. What is much more urgent is this one. Pull that one out. And remember, this is the one with the leaf spring I have added. That's the old one, that's the new one. You won't see a big difference, but if you put them straight on top of each other, yeah, you see it. On this one, that's actually that little piece of metal I use to detect where I am. Since I have inductive sensors, so I need a piece of metal, so metal detectors basically. So I have this piece of metal in here to be able to see it with the sensor. And the only thing I've done is quickly go into CAD, move that one up by 0.5 millimeter. Oh, and by the way, I see it is broken. Yeah, it's a bit weak, the whole thing. I'm curious if I can get this one in without breaking it. Yeah, let's do it the right way. I have invested into a nice little press like this. I haven't shown you that, right? So let me show you that. That is much better way of doing things because you can nicely be parallel to what you're doing. And it hasn't broken this time. Put the whole thing back in, get my leaf springs, my triple leaf spring, because one was not enough. And I mean, that's the cool thing with these leaf springs. You can just add them up until you have the right strength. Add some supports in here. Yeah, that should be good. Now we have this pin here that aligns, that keeps it straight. That's just the direction it goes in. So, and now look at the sensor. Cup in is 0. Cup in is 1. 0, 1. 0, 1. Yes. The sounded a little bit because it's stuck. I mean, it has again the same problem of many 3D printed parts that it is not perfectly straight. I'm pretty happy. So basically, I have the filling that works, and that was the trickiest part. And now I just have to combine everything together. So if a glass comes in, move it onto the scale, fill it, move it out of the scale, and so on. This whole logic is missing. The other thing is my cup magazine. The cup magazine, with these friction wheels, works in principle. The principle is not too bad. But since it is based on friction, and I want to be able to deal with a larger or a smaller stack of cups, right? As you see now, I have pretty large stack inside. Here I have a pretty large stack. If I have a larger stack, I have more weight. Everything will go further down. And then I need to less go forward until my little latches catch the last glass before I move up and the last glass goes down. Then if I have a smaller stack, everything will be higher up because there's less weight. So that is a bit of an issue that I have. I have my tuning variable for this. It is down here. That is the cup magazine advance variable. And now let's test the cup magazine. There's one problem is about the advancement. Okay, we have a big stack, everything goes far down, so I ejected 2 glasses at a time, which is not what I want. Second try. 2 again, because of a large stack. I can go reduce my advance, like to 36%, let's try that. Save the settings. And I have only 1 glass. A second thing you see, the dropping glass is an issue, but I'm curious. Let's check if the glass is detected. So what do sensors say? Yes, the glass is detected. That's cool. That's cool. That's very cool. If I remove this whole stack, because assuming it's the end of the party, you don't have enough glasses anymore, so I have only that little stack. I'm in the right mode. That one works, that's nice. Oh, by the way, I can also get rid of that one. See, but that one doesn't work anymore. To fix any problem in engineering, since I'm still in the triangle electric mechanic and software, you have 3 approaches. You can do it on software, you can do it mechanically, or you can do it electrically. Electrically, you could add a sensor to measure how high you are or to detect where you are and then adjust the software accordingly. Pure software solution, you're doomed because you have no idea what's going on. So you cannot figure out an algorithm that somehow out of the blue detects what the hell is going on. So that doesn't work. A mechanical approach is my favorite because I don't want to add another sensor. The mechanical approach, I'm thinking of something, but that's for the future. We'll see that later. But yeah, so that is about the status. I can fill glasses, I can move stuff. The new design, I'm pretty happy with it. Of course, it has some minimal flaws down here. I'm pretty happy with this setup, even if it's bubbling, because the cool thing is now, over here, I can shut off the air, blow off the air. Now the air goes out. Now everything is pressureless. And now that is pressureless down here, I can, since the good thing is, the cheapest way to get a kind of a connector to that one of the cheap ways was to get this Y piece, and this Y piece has 2 valves in it, which is pretty cool. That one of the ideas is that I can quickly disconnect this one in order to take off the cover. I can disconnect the hose here in order to open it up here to fill the water back in. Because in the end I have a 2-liter vessel. No, 5 liter. It's a 5-liter vessel. But I mean, 5 liters, if you're testing, they're gone pretty quickly. But then, since I have the Y piece, I was like, yeah, let's use the other side of the Y to just put the water back into it. And then I needed the funnel. I still had this thing from my spray gun. And so now I can directly send the water back down into the keg and restart testing. Water goes in. Then I close this one and I'm ready to go again. So I have improved my test setup. I have realized some things like the hose I would have gotten one with thinner walls because I'm going that hose is rated to 10 bars. And I realized I go to 2 bars max. I could have a thinner hose, which would make everything easier, less stiff to move and stuff like that. But yeah, that had to be reordered. Like the stepper drivers, I realized that going for the cheapest stepper drivers was not a good idea. That is my programmer with that monster switch, because the monster switch, like, it has a B and a R here, and it's 0 position. 0 position means no power is going to the chip from this side. R is for run, so it runs it. Boot, it runs it, gives it power, but it keeps the boot pin connected to ground to bring it to boot mode. For the ESP32, yeah, it works. Yeah, another thing I had to learn with my PCB here, I added 2 of these linear regulators here. I had 2 of these linear regulators, one here and one here. And I had to realize that using a linear regulator to go from 24 volts down to 3.3 is a bad idea, because you are basically burning all the energy in between, because it's not a step-down converter. It really converts all the difference to heat. And since an ESP32 at full power draws nearly half an amp, 500, 600 milliamps or so, then it's on Wi-Fi really connected. So basically I had issues with that. So I had to use this DC-DC converter I got off AliExpress and hook that one in here and slightly modify my PCB, cut the trace here, make a new trace here. I had to cut the trace here, make a new trace here, and connect all these wires to where originally my DC-DC converter, my linear converter was. Oh, on this one I also added a second capacitor, but that's not needed. The one I have up here is without the second capacitor. But in the meantime, yeah, we're getting somewhere. That's basically the update. I mean, getting somewhere, as I said in my last short video from the mountains, it's the grind. It's the grind. I mean, I'll show you a little bit of time lapse of me soldering, tinkering, doing and fighting and swearing and stuff like that, because it's never an easy way. But it's very, very rewarding that if you go, as the Latins say, per aspera ad astra, through the rough to the stars. Next step is really get also the conveyor to work. I'll forget about the cup magazine for the moment. Oh, I'll redesign it, but for now I first want to fill beer.
Shut down right on time. 1.4 by 103.6. Roger, shut down, and we copy 101.4 by 103.6.
So you see here, that is my PWM signal that gets longer and shorter all the time.